Hello, my name is Alex Theedom, and I want to talk to you about the Servlet 4 specification, in particular the server push feature. Now, the best way to see server push in action is to look at the Network tab in the browser's developer tools, while at the same time making a request for a web page. To demonstrate the server push feature, I will first deploy a servlet that doesn't use server push, and show how the request behaves by examining the Network tab. Then I will add the server push feature to the servlet code, redeploy, and look at how the request behavior has changed. I will then dive deeper and use the Chrome tools called Net Internals to see how the browser and server communicates over HTTP2. Now, if you're not familiar with the way HTTP2 works, then have a look at the guide I wrote on my channel at IBM Developer Works called HTTP2 Under the Hood. Right, let's get started and jump into some code. So here in the top panel, I have a pretty simple servlet that activates with the URL show logo servlet. All it does is forward the caller to the show logo JSP page, which you can see here in the bottom panel. This is also really simple. It has one resource requirement, the logo JPEG. Okay, so let's deploy this mini web application. Now the servlet and JSP are deployed, I will open the Network tab in Chrome Developer Tools so that I can see the browser's interaction with the server. I'm going to click here in order to activate the servlet. The Network tab shows the request to the servlet and the JPEG required by the JSP. The two interesting columns are the protocol column, which shows that the protocol used is HTTP2, and the initiator column. This column shows which process initiated the request for the resource. So you can see here the image resource was requested by Chrome's HTML parser, which means that the browser requested the resource after it had received and parsed the HTML page generated by the JSP. This is confirmed by having a look at the timing breakdown phases. Here you can see it says content download, which confirms that it was the browser that requested the image. Now let's contrast this with the way it looks when I use server push to push the image resource to the browser. So let's go back to the IDE. So to access the server push abstraction, I need an instance of the PushBuilder, which I can obtain from the HTTP servlet request instance by calling the new PushBuilder method. So I call from the request the new PushBuilder. Now I have the PushBuilder, I can start to build up the push response. The resource I want to push is the logo JPEG that I know the JSP file requires. So I call the path method and pass it the location of the logo image that the JSP file needs. Now I can call further methods and add query strings and HTTP headers and so on, but I want to keep it simple. So I will just call the push method, which initiates a non-blocking push of the logo image resource to the browser. Now what I have here is a servlet pushing the logo image to the browser before it forwards to the show logo JSP. The image resource will have arrived and have been cached by the browser before the HTML generated from the JSP hits the browser. So there will be no need for the browser to request the image, as it will have already been put into the browser's cache. Right, let's deploy the servlet and see server push in action. Okay, so now I've got the servlet deployed and the Network tab is open. Let's run this example. Now that the page has loaded, you can see in the initiator column that the image was obtained by being pushed to the browser. To confirm this, let's have a look at the timing breakdown phases. And you can see that server push was definitely in play. Receiving push shows that the browser received the image via a server push action and stored it in its cache, and the reading push shows that the browser read the image that was received as a result of the server push. Now, if you really want to see what is happening under the hood of the server push, you can examine the frames that are exchanged between the server and the client. I will use the Net Internals Chrome tool to look at the conversation between the browser and the server. Here you can see all the frames that were communicated between the server and the client. Here in the first frame you can see that it's setting up an HTTP2 session. And here you can see the headers that were sent for the show logo servlet. They were sent on stream ID 1. Scrolling down further, you can see a push promise. This is the server notifying the client that it wants to send a resource. In this case, it wants to send the logo image, and it wants to do so on stream ID 2. So we have two streams in play. We have the original request for the servlet, and then we have the image being sent from the server to the client on stream 2. You can see that the streams are being interlaced. Here you have stream ID number 2, here we have stream ID 1, which is the original request, here we have another stream ID 1, another stream ID 1, and here we have stream ID 2. This is the image headers being sent by the server. Now the server starts sending the image in different chunks, and you can see it's sending these chunks as frames on stream ID number 2. Now this is just a peek into how the HTTP2 protocol works. If you're interested in knowing more, have a look at the guide that I published on IBM Developer Works. Well, I hope you enjoyed my introduction to the server push feature in Servlets 4. You can follow me on Twitter at Theedom and visit me at my blog readlearncode.com. Thank you and goodbye for now.